In Lab 12.1, we will be looking at unsigned adders. The objective of this lab is to gain experience with performing addition, but using the behavioral modeling techniques that are provided in the numeric STD library. All right, what you will be doing is creating a 4-bit unsigned adder using the plus operator from the numeric STD package. You will then get experience typecasting between the inputs, which are standard logic vector, and to an unsigned, use the plus sign, and then typecast back. Okay? You are going to display your inputs and the sum on the LEDs and the character displays of the DE0CB, and you will also show the carry out. The demo is just one demo of the addition working and your upload of your top.vhd. Let's take a look at the block diagram and see where everything's coming in and going out. Okay? What we want to do is bring in 4 bits on the input A and B on the switches. So what you will be doing is you will bring in one of the inputs on switches 0 to 3, slider switches, which are going to be right down here. So these slider switches right here. You'll bring in the other 4-bit argument on switches 4 through 7. So you'll have them down here, and you will sit there and switch them back and forth and put in all the possible input patterns that you could possibly have. Now, there's 16 times 16, there's 256 possible input patterns, so you don't need to do them all. Just do a representative demonstration. You want to check them out for your own reference, but you don't have to show that on your video. To see what they are, let's also put the inputs on the red LEDs that associate with those switches, and also let's throw their hex value on the car decoder. So you will then use a car decoder on the 2 4-bit inputs and drive out to hex 0 and hex 2. Notice that I want you to put them on hex 0 and hex 2 because I want you to space them out so that the character display is kind of closer to where the switches are coming in. And then I want you to take hex 1 and hex 3. Please turn them off. And you remember how to turn them off. You simply drive a hard-coded 1, 1, 1, 1, 1 to them. Okay? These sum, I would like you to display on hex 4. Okay? So take the 4 bits of the sum and display it on hex 4. And then I would like you to display the carry on a red LED, which is LED 9, and also on hex 5. So you are going to drive a single bit onto hex 5. That means you need to take that and concatenate it with 3 zeros to make it a 4-bit input to your car decoder. Okay? Now, this feels pretty dang good. You are going to sit there and flip these things around, and you're going to add them together and verify that it works. The only thing that is not 100% straightforward is that they are going to be displayed in hex. Okay? So, you know, it's easy to say 7 plus 7 is going to be 14, but it's not going to come out as 14, is it? You're going to go 7 plus 7, and you're going to get what? E, right? You're going to get E, no carry. Okay? When you do F plus F, you will get something with a carry, but that's it. That's the entire lab. You're just going to flick through these codes. Boom. You do this. You don't even need a process to do this. You can do all of this after the begin statement as concurrent signal assignments. And that is lab 12.1.